Okay, in this video, we're going to review all of our methods to solve some quadratics, and that's going to involve using square roots and some factoring methods and completing the square. And we'll also go through some sum and difference of cubes and polynomial inequalities. So let's go through the process of solving these problems. This first problem here, we're going to use solving square roots. How do I know I'm going to use solving square roots? Because I see x squared and I don't see an x to the 1 power. All right, so go through, I move to 3. I get 6x squared is equal 594. Divide by 6. And we have x squared is equal to 99. Now, from here, what you would do is you want to take the square root, both sides. Here's where a common mistake happens. The square root of x squared, anytime you take the square root of something to the second power, that makes the absolute value of x. The square root of 99 is square root of 9 times 11, and the square root of 9 is 3, so I got 3 roots of 11. Now that we have this expression written this way, we can take x out of the absolute value, and we have x is equal to positive or negative 3 roots of 11. Okay, next problem I want to solve is I'm looking at x squared minus 9x is equal to negative 8. And get my x's all on the same side here. That gives me x squared minus x is equal to 0. And the method to solve from here is to pull out GCF at the left-hand side. X times x minus 1 is equal to 0. And then now we solve from here. That's going to give us x could be equal to 0, or x could equal 1. Now let's look at a problem that's going to require us to factor a trinomial. So I'm looking, and I want to get everything on the same side. And I know this because I have x squared, and I have an x to the 1 power. So I'm going to get everything on the same side. So I'll subtract the 2. I'll add the 32x. We have 5x squared plus 32x is plus 35 is equal to 0. Now I go through the process of trying to factor. So I have a prime number of 5. So I know I'm going to have 5x and have an x. And I have all pluses, so I'm going to have plus plus. And I got to make 35. Well, my options are 7 and 5 or 35 and 1. And 7 and 5 will work. If I multiply 5 times 5, that makes 25. Add 7 to it. That makes 32. I got equals 0. And then I find the two zeros of these linear factors. So I have x plus 5 is 0. 5x plus 7 is 0. And we get our two values of x. So x would equal negative 7/5, and x would equal negative 5. All right, next problem. Okay, so I worked my way through the process of solving, and I know it's telling us the methods right here on the top, but you really don't know what the method is until you already go through the process of solving. So I'm going to move the 9, get everything on the same side to try to solve for x, and I have x squared minus 16x minus 22 is equal to 0. And then you try to factor it, and the problem that you have is I can't take the factors of negative 22 and make them add up to be negative 16, and so factoring's not going to work. Now, a lot of people will jump into using the quadratic formula, but I'm going to do completing the square because I feel like it's much faster once you get the hang of it. Now, the process of completing the square, you actually want to only have x's on one side of the equal sign. So what I'm going to have here is I'm actually going to have the problem x squared minus 16x. I'm going to leave myself a little bit of a gap. Is equal to 22. So I'm going to go and I'm going to pre-make my next line here. Now, since x has a coefficient of 1, and that's really the way I want it when I do this completing the square process, that means I'm going to have some binomial that has x in it that's being squared. Now, to get what goes inside the binomial, you're going to take the coefficient of the non-squared term. You're going to divide that number into 2. So I divide it by 2. That gives me -8. Now you're going to come back up to this next line, because I need to come up with the number that would make that a perfect square, which means you take -8 and you square it and you put it up here in this box. That makes +64. Now, because I added +64, which was non-existent on the left, I have to put +64 over here on the right-hand side. So I have 22 plus 64 on my right-hand side, which means that the equation that I'm trying to solve now is x minus 8 squared is equal to 86. Now we continue the process of solving. Well, if I wanted to solve, next thing I would do would be take the square root of both sides. The square root of the square that I have on the left-hand side makes the absolute value. So the absolute value of x minus 8 is equal to the square root of 86. And we can worry about simplifying the square root of 86 in just a minute. Now when I go to take off the absolute value, it makes x minus 8 is equal to positive or negative the square root of 86. And then I would add the 8 over. So x would equal 8 plus or minus the square root of 86. And I'm just going to leave it like that. In fact, if I start trying to break it up into perfect squares, 4 doesn't go into it, and 9 doesn't go into it, and I don't go much higher than that. So I'll move on to the next part. So now let's complete the square. And we'll have a problem here with completing the square when I don't have a coefficient of that squared term of 1. And we'll go through that process. So I'm kind of letting the cat out of the bag that we're going to complete the square. And so what I'm going to do is I'm going to go ahead and move the 106 to the right-hand side. And that gives me 10x squared plus 20x is equal to 100. Now, sometimes we're fortunate enough where we can go through and solve this thing by completing the square. And we can make that coefficient 1 by dividing everything. And there's nothing wrong with doing that. There are times if you're writing equations, you would have to factor this number out instead of dividing it. But since we're solving, why not go ahead and make our lives easier and divide by this number? So we'll divide the whole problem by that coefficient of the x squared. And that gives us a problem of x squared plus 2x equals 10. And notice how I left myself a gap here to fill in the part for my perfect square. So I'm going to pre-make my line up under this one. And so I take the square root of this number now, since it has a coefficient of 1, that's just going to make x that goes inside of this binomial I'm squaring. Then you half the number of the non-squared term, and you put it down as the second term of the binomial, so that makes plus 1. Square that number that you just wrote, so 1 squared makes 1. And whatever I put in that box on the left, I have to put in the box right here on the right-hand side, which means that I now have 11 over here. And then we want to finish solving. So our problem to solve is x plus 1 to the second power is equal to 11. We go through the process of finishing, we'd want to take the square root of both sides. So my left-hand side is the square root of 11. The square root of x plus 1 squared is the absolute value of x plus 1. And now to finish, to take the x plus 1 out of the absolute value, you have to account for two numbers. Here, that would be either the positive or negative square root of 11, and then move the 1 away from the x. Negative 1 plus or minus the square root of 11. And let's go over one other factoring technique. And we're not actually going to solve this one because I don't have an expression that has an equal sign. But this is going to kind of refresh on factoring by grouping. You usually encounter these problems when you have 4 terms, and what you try to do is you try to group these into pairs. And so I'm going to group these into pairs, and we're going to try the first two together. So 20x to the third plus 5x squared. And then I'm going to group the second set in a pair as well. So I have to have a plus sign in between these two, which means I'm going to have negative 12x minus 3 in this second set of parentheses. And now we're going to work to take out the greatest common factor of both. So if I take out the greatest common factor of the first set of parentheses, that would be 5x squared. If I take out 5x squared, that's going to leave me inside of here with 4x plus 1. And then now I work to go to the second set of parentheses, and I do the same thing. I want to take out the GCF. The greatest common factor there would just be to pull out a negative 3. And you pull that out, and what you have left inside of there is 4x plus 1. Now notice what happens here is you now have a GCF of the two terms of 4x plus 1. And so to complete my factor by grouping, I'm going to pull out the GCF of those terms of 4x plus 1. And then when I do that, what remains is what I have in blue, 5x squared minus 3. Now let's go through and do some sum and difference of cubes. So the sum and difference of cubes formula, if you don't remember it, are right here in this part of the video. And you can just pause it to write it down if you needed to or to refer back to it. Now, if I want to solve a problem involving the sum and difference of cubes, the first thing you have to do is you have to factor it. The way you would factor it is you need to look at this problem in terms of what's actually being cubed. 8 is 2 to the third, and I have x being raised to the third power. So when I go through the process of factoring it, what you're going to do is you would write this as 2 plus x times the first term raised to the second power, which would be 4, minus first times last, so minus 2x, and then last term squared, plus x squared. Now I still have equals 0 here. And then I want to solve. So I'd have 2 plus x equals 0. And then I'd have that second set of parentheses of 4 minus 2x plus x squared is equal to 0. So we'd have x equals negative 2. And then we'd have to solve this second trinomial. That is always a non-factorable trinomial. So we're going to use completing the square to finish this problem because it's always a non-factorable trinomial. I'm just going to rearrange the terms. And then I'm going to go through the process of completing the square. All right, so now we have x minus 1 raised to the second power is equal to negative 3. We go through the process. We'll take the square root of both sides, and we're going to have non-real answers, and that's fine. So a lot of times you will encounter this, and so what I would have would be I roots of 3 on the right-hand side. My left side, taking the square root of the square, is going to make the absolute value of x minus 1. And then we would finish the problem, and we would get x is equal to 1 plus or minus I roots of 3. Okay, now let's go through one where we have a difference of cubes and working our way here through solving. And just like the previous problem, you want to write this in terms of the two cubes. 216 is 6 to the third power. And then when I go through and I factor, that would make x minus 6 times square of the first term, x squared, opposite sign, so plus, first times last is 6x, squared the last number, plus 36. And I got equals 0. And so we get our first answer of x is equal to 6. And that second factor, the trinomial, that is always non-factorable. You'll never be able to factor that one. So we're going to work to go solve it. I'm just going to solve it by completing the square because I feel like it's the fastest one to do. And so I'd have x squared plus 6x is equal to negative 36. Go through my process. So it'd be x and then plus 3 to the second power squared at 3 That makes plus 9 on the right hand side, and negative 36 and 9 make negative 27. And then finish from there. We take the square root, and the square root of x plus 3 squared is the absolute value of x plus 3. The square root of negative 27 is going to be 3i roots of 3, because 9 times 3 is 27. Square root of 9 is 3. And take the absolute value off. That would make plus or minus 3i roots of 3. And we move the 3 over, so it'll be negative 3 plus or minus. All right, solving sum of cubes where the coefficient is not 1. So first problem here, you look and you try to apply the sum and difference of cubes formula, and it doesn't necessarily work out because I don't have two perfect cubes. However, this problem, I could just divide everything by 2 and rewrite. I have x to the third power plus 27 is equal to 0. And then that's a sum of cubes, x to the third plus 3 to the third. And now I factor it and then work my way to solve. All right, let's do one more of these cubes problems. This time we have a difference of cubes. We have coefficients that are not 1, and we can't just divide off the coefficient from this case, or else we would have to deal with a terrible fraction the entire time. So let's rewrite this problem showing exactly what's being cubed. 64 is 4 being raised to the third power, so I really have 4x to the third. 27 is 3 to the third. And now I can go through the process of factoring. And so this would make 4x minus 3 times first term squared, 16x squared. Change the sign. First times last. Square the last term. And then we would solve. All right, now let's review some of our process to solve problems that deal with radicals. And so if I just have a single radical in my problem, what you're going to do is you're going to isolate the radical. So I'd move the 7 to the other side. And then from here, I would square both sides. And then proceed to solve. If you have a radical equals a radical, what you would do here is basically, since I have the same function being applied to my entire left side as I do the right side. I could either A, just set the insides equal to one another, or B, you could undo the radicals by squaring both sides. Both methods work here, and so you'd say 3x plus 35 is equal to negative 15 minus 2x, and then solve from there. Now, if I have a radical equal variable, what I'm going to have to do is I'm going to have to isolate the radical, which it already is, and then to take the radical off, I'm going to square. So I'm going to square both sides, and then rewrite. So we'd have negative 14 plus 9n is equal to n squared, and then we work our way through the process of solving. So I'm going to get everything on the same side, try to solve this by factoring. And so that'd be n minus 7 times n minus 2. And we get two possible answers. Notice I don't say two answers, two possible answers for n. N equals 7, n equals 2. And what I do is I want to check these numbers by putting them both in where n is and make sure we're not outside of the domain. For instance, n cannot be negative because the square root cannot output a negative number. And also, if I put in numbers for n, I have to keep the inside 0 or bigger. 7 times 9 minus 14, bigger than 0. 2 times 9 minus 14, bigger than 0. Two answers. And then last one here with the radicals, radical equaling a binomial. Well, anytime I want to solve a radical problem, I have to isolate it. So I need to move the 5 to the other side. And then to take the radical off, you got to square. So I got to square everything and then go to solve. Okay, last thing in this video, reviewing our solving methods for quadratics and polynomials and even some radicals, is to look at some polynomial inequalities. So when you're trying to solve a polynomial inequality, what you want to do is you want to have one side of the inequality as 0, and then the other side, what you're going to do is you're going to hopefully be able to factor it, and more times than not you're going to be able to. And so I have this left side factored for the first one. The right side has to be 0. And what I'm going to do is I'm going to find the zeros of these two factors. So I have a 0 of 2 for the first factor, and I have a 0 of 3 for the second factor. And since we have an inequality, we need to find the set of all numbers that will keep that left-hand side less than 0. So I'm going to do a sign test. I'm going to put those two zeros on a number line here. Now I know that those numbers 2 and 3 actually make that left-hand side equal 0. And when it comes to writing my answer, I'm going to have to exclude those numbers because I want to be less than. So what I do is I'm going to pick out numbers in between or around 2 and 3 and see what kind of sign does it give me there on that left-hand side. So for let's start testing to the left side of 2. Let's pick an easy number like 0. If I put in 0 for the x's, I just want to know what's the sign of the left side. If I put in 0 for x, I have negative 0 plus 2, positive. 0 minus 3, a negative. So I have a positive times a negative, which makes a negative number. So all numbers less than 2 for x are going to be negative. Now let's pick out a number in between 2 and 3. So let's think like 2.5. So if I put 2.5 in for x, negative 2.5 plus 2, negative, times 2.5 minus 3, negative. Two negatives multiplying together make a positive. And then lastly, let's pick out a number bigger than 3. So let's look at 4. Take a number like 4, put it in for x. Negative 4 plus 2, negative. And then 4 minus 3 makes positive. Negative times a positive makes a negative. So since we want to be less than 0, we're going to use all of the intervals that produce negative signs. So our answer here would be negative infinity to 2, not inclusive because I'm not allowed to equal 0, and 3 to infinity. Same thing here. This problem, I want to be greater than or equal to 0. So I need to go find all my zeros of this. I got x is equal to 8, x is equal to 7 over 2, and I have x is equal to 1/2. I'm going to make a number line, and I'm going to do a sign test. So from least to greatest, we have 1/2, 7 over 2, and we got 8. All right, so we'll pick a number around those. So I'm going to start with a number smaller than 1/2, an easy one like 0. So if I pick a number like 0, put it in for all my x's, see what I get. 0 minus 8, negative. 0 minus 7, negative. And then 2 times 0 minus 1, negative. 3 negatives multiplying together make a negative. Now pick out a number between 1/2 and 7/2. How about 6 over 2, which makes 3. If I put in 3 for my x's, 3 minus 8, negative. 2 times 3 minus 7, negative. 2 times 3 minus 1, positive. 2 negatives make positive. And then pick out a number between 7/2 and 8. Doesn't matter. Let's pick out 7. I know 7's in between there. So if I put in 7 for x, 7 minus 8, negative. 2 times 7 minus 7, positive. 2 times 7 minus 1, positive. I have a negative number. And then lastly, I got to pick numbers bigger than 8. Let's go with 10. If I put 10 in, 10 minus 8, positive. 2 times 10 minus 7, positive. 2 times 10 minus 1, positive. So our inequality sign tells us we want to be greater than or equal to 0. Now notice all of these numbers make the left side equal 0. So since my inequality signs include those numbers, I have to include them in my intervals. So greater than 0, we want to go from 1/2 to 7/2 inclusive, and bigger than 8. Now let's do one where the problem is not factored for me. And so I need to try to factor this. And so going through that process, one of the first things we do in factoring is a lot of people don't like having a negative sign right here, is I could divide my whole problem by a negative 1 if I wanted. And if I do that, that makes x squared plus 11x minus 21. Remember, when you divide both sides of an inequality by a negative, you got to turn the sign around. And then now I'd go factor. So I go factor this. 21, 7 times 3. 7 times 3 is not going to make 11. Oh, I forgot the 2 there. That would explain it. So let me make myself room. We'd have a 2x here. All right, 7 times 3 to make 11. That would be minus 3 plus 7 here. We get our zeros. So 3 halves and negative 7. We're going to do our sign test. So negative 7 and 3 halves. We know that both of those make our left side equal 0. And we're going to test around those numbers. So I pick a number smaller than negative 7. I'm going to put it in my factored form. So I don't know, let's go negative 10. I put negative 10 in for x. Negative 10 times 2 minus 3 makes a negative number. And then negative 10 plus 7 makes a negative number. 2 negatives multiplying make a positive. Now let's go inside the next interval. Pick a number between negative 7 and 3 halves. So I'm going to pick 0. Put in 0 for x. We get negative number times positive number. Negative number times a positive number makes a negative. And then lastly, we pick a number out bigger than 3 halves. So a number bigger than 3 over 2 would be 2. So I'm going to put 2 in and test it. 2 times 2 minus 3, positive. 2 plus 7, positive. Positive times a positive makes a positive. And so we want to be greater than 0, but not equal to it. So our answer would be negative infinity to negative 7, non-inclusive, on the negative 7, union 3/2, non-inclusive, to infinity. There is our intervals of possible answers. 1. So again, another polynomial inequality that's not factored. Get everything on the same side. One side has to be set equal to 0. So we'd have x squared plus 9x plus 20 greater than or equal to 0. And we go to factor that. That'd be x plus 5, x plus 4 is greater than or equal to 0. We have our zeros here of negative 5 and negative 4, so close together on this number line. And so I have negative 5 and negative 4 here, and I'm going to test around those numbers into my factored form. So I'll pick a number out smaller than negative 5 to test, so like negative 6. Put negative 6 in for x. I get a negative times a negative. Two negatives multiplying together make a positive. Pick out a number between negative 5 and negative 4, so negative 4.5. Put negative 4.5 in, positive times a negative makes a negative. And then pick a number out that is bigger than 4, negative 4. I'm going to pick 0. Put 0 in for x. Positive times positive makes a positive. Now we go to build our solution set here. Remember, those two numbers, negative 5 and negative 4, make the left side equal to 0. And since our inequality sign says greater than or equal to 0, we include the numbers that make it equal 0. So we'd say negative infinity to negative 5, inclusive, union, negative 4 to infinity.